Welcome to Spring LIB.
Hi, in the given problem, mass of the person standing on the cylinder is given as 70 kilogram. So, when he'll stand on the cylinder will dip a little more in the water, in the salt water. Let it be H, means the cylinder is dipped into the salt water by a height of H meter further. So, the as per Archimedes principle, weight of the more water displaced will be equal to the weight of the person. As diameter of the cylinder is given as 0.900 meters, so its radius is 0.900 meter by 2, means 0.450 meter. This is the radius. Hence, we can say the weight of the person, means mg, will be equal to weight of the more water displaced, means v rho g. So this g will be cancelled. For m, this is 70 kilogram. For volume, it will be area of the cross-sectional area of the cylinder, pi r square into h. The more height of the cylinder dipped into the salt water. And as far as density of the salt water is concerned, this is 1039 kilogram per meter cube. Hence, the expression for height will come out to be 70 divided by pi r square into 1039 for the density of the salt water. Hence, here this is 70 divided by 3.14 divided by 0.450 to the whole square and 1039. So finally, when we calculate it, this height comes out to be 0.106 meter. So this is the answer for the first part of the problem, in which we have to find the height of the cylinder which will be dipped. This is the height of the cylinder, the additional distance the buoy will sink when this 70 kilogram man stands on top of it. Now, in the second part of the problem, they are saying if this person dives off the buoy, then what will be the time period of oscillation of this buoy in the water? So when this person jumps off, then the cylinder will experience a restoring force, and that restoring force will be given by, this is the restoring force, F is equal to the weight of the water displaced again, and this time the height h will be variable, because this height h will be gradually decreasing when the man jumps off this buoy. So it will be given as negative, because its direction is opposite. So this is negative pi r square, the area of cross section of the cylinder, into h into rho, the density, and then finally g. So it comes out to be minus 3.14 into 0.450 to the whole square into, for density, this is the same 1039 into g, 9.8, and h finally, which is variable. So this force here comes out to be minus 6471.9 into h. Hence, as this force is depending directly on the displacement, so we can say this buoy will start doing a simple harmonic motion. And if we compare it with F equals to minus K h, or we can say delta x. Here delta x is the displacement, and here h, this h is the displacement. So we can say spring factor for this oscillatory motion will be 6471.9 Newton per meter. Hence the time period of this simple harmonic motion will be given by 2 pi under root inertial factor by spring factor. And inertial factor is the mass of the cylinder, which is 950 kilogram, and for K this is 6471.9 Newton per meter. Hence this time period finally comes out to be 2.41 second, and this is the answer for the second part of the problem. Thank you.